Alright, we're going to talk about logarithmic properties. I'm just going to tell you right now, my nerdy little secret is that I think these are fun. They are using the properties of logs to expand or contract expressions. Why do we need to do that? Well, sometimes we have something we're solving for that's stuck up in the exponent or stuck into a log, and we need to be able to expand it out to untrap that variable so we can solve for it. Remember that logarithms are really just exponents in disguise, given the definition. Remember that log base b of x equals y if and only if b to the y equals x. So sometimes a lot of these rules are cousins or have leanings to our exponent rules. So anytime I have log base a of 1, it equals 0. And that's because a to the 0 equals 1. Anytime you have the same base and argument, so log base a of a always equals 1, and that's because a to the 1 equals a. Inverse properties, so if you have a and then raise it to the log a, these cancel each other out and you get x. And anytime you have the same base as the argument, then they cancel each other out and you just get x. And they have these for base a and base e. Remember, natural log is just log base e. So really these apply to every log. Anytime you take the log of two things multiplied together, they're added, because in our exponents, if I have x2 times x3, it's actually x2 plus 3. Okay, so if you have multiplication here, we're going to expand them by adding them, or if they're originally added, you can write them as a multiplication. Same thing when you have x3 divided by x2, that becomes x3 minus 2. So log of a division can turn into a log of a subtraction, or vice versa. And then if I have log base a to a power, I can take this power and bring it back to the front as a multiplier. Alright, so let's look. We're going to use the properties of logarithms to expand this guy here and simplify it if possible. So these are all multiplied, so I'm going to rewrite them as added. So log base 4 of 2 times, or plus log base 4 of x cubed plus log base 4 of y squared. And see, we have powers here, so we can use the power property. So log base 4 of 2 plus, so this will come around here and become 3 log base 4 of x, and then this will come around here plus 2 log 4 of y. Alright, now this one's a little bit more complicated because this is the fourth root, so that's really log base 2 of x cubed 3xy squared z all to the 1/4 power. So we have the power rule so that we can let these guys escape. So that equals 1/4. Now I put a brackets around, so because this 1/4 now will be multiplied by whatever comes next. So you can't forget to multiply it times everything. So this here is a division, so that would be log base 2 of x cubed minus log base 2, let's look at the leg, log base 2 of 3xy squared z. So that's 1/4 log base 2 of x. Actually, I can go ahead and bring this 3 to the front. That's one less step I have to write, so I'm going to let this 3 come over here. So it's 3 times log base 2 of x minus, and now I'm going to have everything in these parentheses, log base 2 of 3 plus log base 2 of y squared plus log base 2 of z. So that's 1/4 times 3 log base 2x plus, nope, that's a minus, log base 2 of 3. Remember, I can bring this over and it's a power rule, so minus 2 log 2 of y minus log base 2 of z. And if you wanted to, especially some textbooks have you go ahead and distribute this 1/4 in. It's really whatever you prefer, unless you're told to. Okay, so now we have, it says condense using the properties of logs. So let's see if I can do this. So this is a plus, so this is multiplied. So this is log base 4 of 3x minus log base 4 of y. So this is a minus, so it was division. So log base 4 of 3x over y. Alright, so this is the product rule. We've already talked about it. If it's multiplied, we add them. So let's expand this one. So mathematicians are inherently lazy. I would resist the urge to go ahead and multiply this in and then try to work it out. This is multiplied times this, so I can write it as log base 3 of 30x plus log base 3 of 3x plus 4. And 30 is actually 3 times 10, and 10 is 2 times 5, right? So this is really log base 3 of 3 times 2 times 5 times x plus log base 3 of 3x plus 4. And that just stays its way because it's inside the parentheses. And that's an addition. So this becomes log base 3 of 3 plus log base 3 of 2 plus log base 3 of 5 plus log base 3 of x plus log base 3 of 3x plus 4. And I told you anytime you have the same base and argument, that becomes 1. So this is 1 plus log base 3 2 plus log base 3 of 5 plus log base 3 of x plus log base 3 of the quantity 3x plus 4. Alright, so this is a minus one. And like I said, I would resist the urge to multiply it out. I would just write this as, so this is division, so that it's the top minus the bottom. So this is log base 2, 15x times x minus 1 minus log base 2, 3x plus 4, 2 minus x. And then this is multiplied, log base 2, 15x plus log base 2, x minus 1. This is multiplied, so that's addition, but keep this minus here for everything. Log base 2, 3x plus 4, plus log base 2, 2 minus x. And now 15 is 3 times 5, so this is log 3 times 5 times x, 15x. So this becomes log base 2 of 3 plus log base 2 of 5 plus log base 2 of x plus log base 2 of x minus 1. Take this negative in to both of these, log base 2, 3x plus 4 minus log base 2 of 2 minus x. Big mess. Alright, so here's my power rule. So let's expand this guy with the power rule. So this can come back here. So this becomes 5 times the log base 2 of x. And now we can rewrite this one. If I could get something, well, let's do 25. What is 25? 25 is 5 times 5, right? So it's log base 3 of 5 squared. So this comes around here, and I get 2 times the log base 3 of 5. And then they want me to rewrite 4 natural log x using the power rules for logs to a single logarithm with a coefficient of x. So we're going the other way, in reverse. So if I have 4 natural log x, well, I can rewrite this. This now can come up into a power. So natural log x to the 4th. So now we're just mixing it all up. So this is the natural log, this is division, so we're going to subtract the top from the bottom. And then this is multiplied, so this becomes natural log x to the 4th plus natural log y minus natural log 7. And we have a power here, so that becomes 4 natural log x plus natural log y minus the natural log of 7. And let's look at this one. So remember, the square root of x is really x to the 1/2 power. So this becomes log, to simplify the radical expression. So log base x to the 1/2, that comes over here, and that becomes 1/2 times log base x. So now we spread them out. Now we're going to squish them back together. So these two are, first of all, make sure they don't give me a trick question. We have to have the same bases on all of these. So these are added, so I bet you this was log base 3 of 5 times 8 minus log base 2. And then this is log base 3, or missing my bases, log base 3 of 40. This is minus, right? So this would be divided by 2. So this is log base 3 of 20. Alright, condense this guy. So this into single one, so this is added, so they were multiplied. But, oh, look, I have a power here. So this is log base 2 of x squared plus log base 2 of x minus 1 quantity squared. And you can do that with this one too. Log base 2 x plus 3 squared cubed. And so this becomes, these are added, so they're multiplied, so log base 2 of x squared times x minus 1 squared minus log base 2 of x plus 3. 2 times 3 is 6. And then these are subtracted so they can go as a division. So this is log base 2 x squared x minus 1 squared. Oh, that should have been a 1/2. So division, so x plus 3 over 6. So this becomes log base 2 x squared, x minus 1 to the square root of x minus 1, because 1/2 power is the square root, x plus 3 to the 6th. Alright, let's try another one. So let's take care of all these power rules. So this would be log x squared, at least I don't have to rewrite a base with each one of these, minus log x plus 5 to the 4th power, plus log 3x plus 5 to the 1 over x power. And these are this is going to be division and then multiply, and that's fine, but I can also multiply these and then divide that way. So it's kind of whatever you're comfortable with. So this becomes log x squared over x plus 5 to the 4th plus log 3x plus 5 to the 1 over x power. And so these are added, so they're multiplied, so log x squared 3x plus 5 to the 1 over x power, x plus 5 to the 4th. And if you wanted to, you could leave it like that. You could also rewrite it as 3x plus 5 to the x minus 1 power, x plus 5 over 4. Alright, so change of base formula. So a lot of calculators, you can calculate whatever base, but growing up I only had the option of natural log or log base 10. So if it didn't come in log base 10 or natural log, then I couldn't calculate it. You can use this with log base 10 or natural log. I always choose natural log because I'm lazy and I only have to write ln instead of log, and you've seen how many steps for each one of these problems. So if I have a choice, I always use natural log. People laugh at me, but if you think about the insane amount of math I've done over my life, it's saved me a lot of writing. So to change the base, I would take the log of the argument and the log over the log of the base, which turns into the natural log of m over the natural log of b, or equivalently the log of m over the log of b. So if I need to change log base 5 of 3, I would do log of 3 over log of 5, or you can write natural log 3 over the natural log of 5. And did it say I would just change to a quotient? So either one of those is correct. No, it's not, because this says natural logarithms here, so that's not correct. It is correct, but that's not what they asked for. It's one of my problems. It's how I lose a lot of points on math tests, because I get gung-ho and start writing stuff and then forget to look at the what they actually wanted. Okay, so this can be written either log base 10 over log base 2, or natural log 10 over natural log 2. And if I put it in my calculator, I get approximately 3.3219. So let's put it in my calculator. So if I have log 10 divided by log of 2, it gives me that number. And if I do natural log 10 divided by natural log of 2, I get the same number. Alright, have fun. Here's some more videos if you need clarification, and you can always reach out to me as well.